access to this recording once we're finished, and I'll show you where that goes. And the next thing I'm going to be doing is I'm going to be sharing my screen with you. I'm going to start out with my browser. Okay, so everybody should see my screen right now, but what I'm showing you is our course. Okay, so everybody should be seeing our Canvas course. I know you're all in it because the student information system puts you in it, but only a few of you have actually started working in it. Okay, the course was opened last week, and I realized the official start of classes today, and that's fine. But let me just show you the way the course is laid out. And like I said, if you've got a question, feel free to unmute yourself and just ask the question. Again, I try to keep the chat open while I'm screen sharing, just so everybody can type. Okay, so there's this Start Here module, and you'll see that the assignments in it are due by Friday, January 22nd. Okay, so what's in here? There are some live online lecture expectations in here. Okay, and again, I apologize. I will go in and change the Monday, Wednesdays to Tuesday, Thursdays. I got most of them, but I did not get all of them. This class is offered on Monday and Wednesday in the fall and Tuesday, Thursday in the spring. So we're Tuesday, Thursday. Okay, so this tells you how to prepare and basically what technology you need to have working. Okay, there's an introduction. And what that tells you is there's a little video there where I kind of walk you through the course. And it tells you what the required skills are. And it also has a college algebra video playlist if you should want to go back and review any of that material. Okay, here are our general course learning outcomes. Okay, so you want to be able to recognize limits, continuity in various forms. You want to be able to manipulate derivatives and integrals and be able to apply them in business contexts. Okay, so again, I'm going to be teaching you skills. You're going to be learning basic skills about calculus, but the most thing is to be able to apply those skills. Okay, nobody's going to come up to you and ask you, hey, what's the derivative of this function? They're not, but they may ask you, how fast is our profit changing when we're making so many thousand of our product? Okay, that's a calculus question, but you've got to be able to recognize it as such. Okay, so again, some additional information about the course here in introduction. I'm gathering most of you saw how to join a WebEx meeting from Canvas, and that's what got you here. Other things I want to share with you is here's tutoring information for the spring. Tutoring this semester is going to be entirely online. And again, I apologize, Canvas is being super slow here. Again, they're showing you their hours of operation. And again, they're showing you how to get an appointment. Okay, you actually have to sign in to get an appointment. Again, it hasn't been shared with me, but what I've known in the past is a lot of the tutors who tutor calculus in the tutoring center are tutoring the calculus for engineers, okay? I'm not saying they can't help you with calculus, but I would ask that you would reach out to me first if you're having trouble in the course or you need a quick catch-up session. We can set up a quick WebEx meeting anytime you want. With my schedule, I have office hours posted in the course, but what I've found from experience with live online is those usually don't work for most students because you're in other classes or you're working yourself. But if you reach out to me with email and you say, hey, Ms. Smith, can you please set up a meeting with me at this time? And I will send you a WebEx invitation for a meeting and we can talk one-on-one about wherever you're stuck. Okay, so like I said, feel free to reach out to the college tutors, but please realize a lot of these folks can do calculus, but they won't understand the business applications of calculus. They're engineering students, okay? So just wanted to share that with you. Okay, the other thing that's super important is how to borrow technology. I realize in this situation that we're in this semester, it's difficult to have what you need in order to move forward. Okay, so borrowing technology includes not only not renting, but borrowing a laptop or a Wi-Fi hotspot, but also a calculator. Okay, so here's calculator requests if you want to borrow TI-84. Now, what I managed to do last semester, since this was not in last semester, I've put a lot of links to online apps in the course. Okay, so if you decide you don't want to go the TI-84 route, basically there are online apps that you can use to provide the same functions. Okay, and like I said, if you're not these links are, please just ask me. Okay, I'd be happy to come with you. So we're not tied to the TI-84, but if you're comfortable with it, you've used it before, this is where you go to rent one. We have a student technology help desk this semester. It started in the late fall last semester. Okay, and basically this is where you would go if you have technology questions. Again, I can try to troubleshoot them for you to start with, but if I'm not able to fix them, you know, if you have problem logging into Canvas or something's not working with your laptop, anything like that, feel free to reach out to these folks here. The other stuff that needs to be done by Friday, because again, you notice not everyone in the course managed to log into our WebEx meeting today. The way I'm taking attendance in this course is through completion of assignments in Canvas. Okay, it's more reliable than making sure everybody makes every WebEx meeting, although I encourage you, please come to the meetings regularly. Okay, it's where you're going to get your questions answered. Okay, so the stuff that you are going to be doing by Friday is this little pretest, which is mainly for you to have you figure out how comfortable you are with college algebra, because I know some of you probably took it a few semesters ago. There's an online learning survey for me, so I can figure out how comfortable you are with learning in the online environment. There's a syllabus quiz. And again, you can see over here in Canvas, there's a link to the syllabus right here. I'm going to click to it. There's a downloadable syllabus file, which I encourage you to download and read. Take a look at it. It has a schedule as the last page, and I will try to stick to that schedule as much as I possibly can. The course is arranged to mimic the schedule in the syllabus. But if I have to deviate from it, I'll make sure to share that in the online class, as well as to change the syllabus itself. Okay, and again, you can see the course summary here on the syllabus page. Let me go back to modules. Okay, my recommendation for you is to navigate the course through modules. Okay, I've set them up so that they are arranged week by week. Okay, I know a lot of students just go straight to the assignments and they don't ever look at the content in the course. The course is arranged to be the most effective if you go through modules. Okay, so again, after you do syllabus quiz, here's a quick file that will explain how to answer questions in our online homework system, which is embedded in Canvas. Okay, you don't need to log in anywhere else. You don't need to buy any access code. You don't need to buy any books. Okay, everything you need for this course is right here in Canvas. Okay, but this is a quick little file that explains how to enter answers in this learning management system that you might not have used before. Okay, so I'd encourage you to read through this. And the last thing that's due by Friday, and some of you have already posted to it, I'm excited to go and actually read your posts. This is a discussion board that is essentially meet your class. Okay, so it's asking you to please post a short introduction with your name, your major, okay? And if you're typing, please upload a photo of yourself so we can see, and we can see some of our students right here who've done this already, okay? So again, I would encourage you, please take a look in here and feel free to respond to each other, okay? I'm trying to build as much of a community among you as I can here, and I'm sure you'll all agree it's difficult in a land of WebEx meetings to build a community. So feel free to respond to each other's discussion posts here. Okay, so that's what needs to be completed by Friday. On top of that, we have week 1 assignments. Yes, I know we're jumping into this with both feet. Okay, and these are due by January 24th. Okay, that's Sunday. The week 1 assignments are going to be the math-oriented things, and you can see the way each one of these week 1, week 2 is arranged pretty much the same. There's a learning activities section, and what that has is a link to our online sessions. I'm going to just open this up to show you what it looks like. Each one of our weeks has this. And again, it talks about our online session recordings. Here's the topic, course introduction and function review. That's what we're doing right now. Okay, there'll be a meeting link here. Okay, although you can get into it from Cisco WebEx right in our Canvas course. Okay, when we're done, I'll upload a link to a YouTube video right here. That's the video we're making right now. And if I've shared any files, and I'm almost always going to be sharing files with you, I'll upload the completed files here. Okay, so if you ever miss a lecture, a session, you can look at the recording and you can also look at the files. Okay. And again, there'll be 2 of these for most weeks, okay, unless we have a holiday in that week. Okay, so you can see our Thursday session is already up here ready to go. Okay, what else is in the learning activities? Okay, there are objectives for each section. So you can see in week 1, we're going to be covering section 1.1, 1.2. Okay, so the objectives for functions, and this is some of the stuff you can preview before you come to class. Okay, again, I think I clicked the wrong thing here. Okay, my bad. I clicked the book, the textbook, instead of the objectives. Okay, sometimes what happens is these jump around. Okay, so again, these objectives tell you what it is we're going to be covering. Define a function, determine if something's a function, evaluate them, look at basic toolkit functions, and look at domain and range. Okay, as well as review interval notation, which again, I'm assuming the majority of you saw in college algebra. And if not, you can always request more support material. There's a video list, okay, that you can look at to kind of help you through the topics. Okay, so again, we have some basic functions. Okay, and then there's a textbook. This is a free online textbook. The sections aren't very large. Okay, there are a couple of pages at most. I think this is one of the longer ones because it's review. This one has 12 sections. And again, it's written in a really easy to read way. It's not the usual mathese that math textbooks are written in, which is kind of why I gravitated to this. Not to mention, I think I said it's free. Okay, but it's written by math teachers who've taught this class. Okay, so it kind of reviews everything. And then what I wanted to show you over here at the bottom, here's basic toolkit functions. Each one of these sections has some exercises. Okay, you can see them right here. Now, some of these I've pulled into our notes, which I'm going to talk about next. Okay, but if you really want to make sure you understood the reading, take a look at some of these questions and see if you can answer them. Okay, so that's a good way to kind of prepare, okay, to see if that's working for you. Okay, and if there's anything in these exercises Again, these are not required. They're not graded. They're for you to check your understanding. And if you've got questions about them, I'd encourage you to ask me, okay? Reach out. Okay? What else have we got? Okay, so that's section 1.1, and you'll see these same things for each one of the sections. There'll be objectives. What are we trying to accomplish? Okay, some videos as well as the textbook. And I understand everybody's crunched for time, and a lot of folks say, well, I'll just look at the videos. I'm not going to bother reading the book. Take a look at the book, even if you skim it, just so you have some idea what we're going to be talking about when we go over the material in class. Ideally, what I like students to be able to do is to have some idea of what we're covering, come with questions, and then we'll do examples and answer your questions in class rather than me talking at you the whole time. Okay? So here's our second section, okay, 1.2. Then we have class notes, okay? You'll have like one or two of these in each week, okay? The first one goes with the first online class session. The second one goes with the second online class section. I'd encourage you before a class to download these notes and have them handy, okay? So you can actually work with us with a pencil, okay? And fill things in as we go along. When I do these together with you, okay, that's the file I'm going to upload to these online sessions. On occasion, I might even use an Excel spreadsheet to help us out, and I'll upload the spreadsheet as well. Okay, but these are kind of like guided notes. They're not the fill in the blank kind, okay, but they're to give you an overview of what we're going to be talking about. Okay. Then we have assignments, okay? So here is the actual MORE, which stands for Maricopa Open Educational Resource. These are the homework assignments. You can see there's points associated with it. Okay, I'm going to click on it so you can see kind of what it looks like. Okay, it's connecting. You don't have to log in or anything, okay? Like, for example, you would just have a start button, okay? And again, here's the due date. You can reload questions if you get them wrong. You can say, let me try another example of this because I got it wrong. So don't feel you're stuck, okay, with a question that you get wrong. It's only going to let me preview it so I can show you what they look like. Okay, so here are the questions, okay? And if I get it wrong, there's going to be try another example. So it will let me reload the problem with new numbers, okay? What I want to show you down here are some helps. You can see this question has videos associated with it. So if you're confused about the question or what it's asking, take a look at the videos. The last link is really important, and there's one at the bottom of every homework question. It says message instructor, okay? Basically what this is it's a way for you to email me with a snapshot of your question with your numbers, okay? And then you can add to your email and say, hey, Ms. Smith, I got partway through the problem, but on the third part, I really didn't understand what they were asking. Okay, so write me a little note, and I will actually walk through the problem for you, okay? If you're still confused, we can set up a WebEx session to go over it, okay? And we can screen share just like this. Okay, so again, there's that file I showed you earlier, how to answer WebEx, how to answer more questions. Okay, so please don't hesitate. Okay, if you, they keep talking about this math quill tool. Okay, sometimes you're going to need to, this one is just click the box. But if you actually have an answer like this one, okay, there'll be a math quill tool. Here's a prompt, but usually there's a little yellow bar over here that will let you bring up a template so you can type in a fraction or an exponent. Try not to like freelance what you think they want as far as exponents or fractions. Actually use the template that's built in. Okay. Anybody have any questions so far? Okay, so I'm typing it in the chat.
Yes.
Yeah.
How many retries do we get on each question?
Okay, my understanding is you can retry the question as often as you want. Okay, so retry
Okay,
until
thank
you
you.
get it right. Here's my advice to you though. If you've tried it 3 times and you keep getting it wrong, hit that message instructor button. If you are taking more than 15 minutes to get started on a problem, hit the message instructor button. Okay, so what I'm saying is don't wait to ask for help. Okay, we're going to be going through a fair amount of material in this class, and I don't want folks to get behind. And the way you avoid getting behind, aside from preparing, like previewing things before you come to class, is by asking as soon as it stops making sense. Okay. For a lot of people, this isn't intuitive. It wasn't intuitive to me the first time I saw calculus. Um, we didn't have any kind of pre-calc or AP calc in my high school. So I came into calculus as a real noob. I mean, I really had no idea what was going on. And luckily for me, I had a patient instructor who gave me some tips. Okay, and previewing was one of them. Asking questions, coming to office hours, those sort of things. So that really helped me out a lot. I was also a first generation college student in my family, and there was really nobody to ask. You know, how do I do college? How do I do this stuff? So again, if you've got those kind of questions, feel free to ask me as well. Okay. All right. So those are the homework assignments. They kind of look a lot alike. Again, here are the 2 homework assignments. I put some optional stuff down here. The optional stuff is optional. You don't have to look at it. Okay, some pre-calculus review material, and then a list of exponents and logarithm properties. Okay, this is kind of a blast from the past. Okay, what you're going to find in calculus is, and I know this sounds funny to a lot of people, algebra is used to simplify things so you can do calculus on them. Okay, that's right. I said algebra is used to simplify things. Okay, so you're going to have a basic understanding of some of the properties of algebra, especially properties of exponents. Okay, so I put this material here for you to review if you need to. Okay, real quick, let me slide on down. Okay, you'll see sometimes I'll put applets in the supplementary materials, and I'll probably demo them in our online class. But if you see anything that's a clickable link like this, it usually means it's an app. Give it a try. Actually play with it. Okay, because like I said, calculus is math of things in motion. And well, apps have moving parts, so it's real easy to see what the concept is you're trying to understand. Okay, I'm going to scroll on down to our first exam. Let's see where that is. I think it's probably around week 4. Here it is. Okay, so week 4, okay, we're going to be doing practice for the exam. Okay, and then there is an exam here, okay, that you're going to get one shot at. Okay, but please do work. There's plenty of time to do the exam. Don't worry about being rushed. Show your work on a piece of paper, and then after the exam, either take a photo, or if you have a scanner, and scan in. There are apps that will take photos and create a PDF out of them. Okay, show me your work. This is a 0 point assignment where you can upload a file. Okay, I really am more interested in how you approached the problem than whether you got the answer 100% correct. I want to see that you're on the right track as far as how you're approaching the problems. So all of the exams have a work assignment attached to them. Okay. If you scroll further down in the course, you can see we have 15 weeks worth of stuff. Here's a final exam. Okay. Here are links to the entire textbook. The textbook is broken up into useful sections as you go through the week by week modules in the course, but here's the whole thing all in one lump if you prefer to look at a textbook like that. Okay. And then what I have here, remember I told you there are some online tools, right? We have a Desmos graphic calculator, okay? A scientific calculator for actually doing number crunching, okay? And here are all the applets and useful files that I put in there, okay? I have to copy the exponent and log rules over here. So everything's all in one place, okay? And then this is something that we've gotten from our student services folks that have general information. This is not related to calculus, okay? But it's general information on how to be a successful learner. Okay, some time management stuff. Some of you mentioned time management in the chat when I asked you how you're successful. So you have those resources here. Okay, basically, I'm going to answer the question generally, okay? Somebody's asking, do we have to use a particular browser for exams, and are we allowed to use our notes, okay? The answers in order are no and yes. In other words, I'm not requiring you to use a lockdown browser because there are too many online tools that you have to access if you don't have a TI-84, okay? Also, you will be able to use your notes for the exam, okay? So not to worry about that. My objective, again, is to make sure you understand the process. So even though you're allowed to use the notes, please, please, okay, show your work in your notebook or on a piece of paper, and then upload that to me so I can see how you're approaching the problems. Okay, and there's one more important thing that I haven't mentioned to you about the homework, okay? And those are called late passes. You'll notice each of the homework, let me go back up to the top. Each of these homework assignments has a due date. For example, 1-1 is due Sunday, and these are Sunday at 11:59 p.m., okay? Because I know a lot of folks try to batch their homework on the weekends. I'd encourage you to at least look at the assignment before the weekend, okay? Although I am available on weekends for questions and whatnot. You can email me anytime you like. I typically respond to questions within a couple of hours through email. That's the best way to reach me. If you email me past 10:30-ish, you'll get an answer at 5 a.m. the next morning, okay? But I will try to respond to you as quickly as possible, okay? So basically, you have these things called late passes, okay? And the late passes are something that comes with more, okay? If you let an assignment like homework go past due, okay, you can then use one of your late passes to open it, okay, and it opens it for a week, okay? I would encourage you, you've got 10 of them, okay, don't go late on every assignment. There aren't enough late passes to do that, okay? Do your best, okay, to stay abreast of the assignments. The reason I'm giving you late passes is so you can manage your own time effectively, okay? You don't need to ask me, hey, Miss, can you open the assignment? You can open the assignment, okay? So let me stop again and ask, do you have any questions on the structure of the course? Any questions at all? Anybody? Okay, again, I've tried to make it flow as smoothly as possible. And again, the objective is to make sure you know what's coming up. Okay, this is not me trying to surprise or trick or whatever. Yeah, the exams look a lot like the homework. Okay, my emphasis is pretty much going to be on slide problems, but I'll show you how to do those. Okay, though that's pretty much what you're going to have to do with this if you use it in your career. Will there be a preview day? Yes, in general, I will be previewing for the exams, and I would encourage you to bring any questions you have. Okay, so like before the preview day, go back and look at your homework. Okay, this is why it's a great idea to work the problems on paper. Okay, so you can then go back into your notes and say, hey, in homework 2.3, number 7, I didn't understand how the answer was this, and I got that. Okay, can you show why that is? Okay, and I'd be happy to do that. Okay, so yeah, we'll preview, but I'm encouraging you to bring your own questions to those preview days. Okay, all righty. Well, again, I'm not seeing any questions in the chat. So what I'm going to do is I typically use an iPad as a whiteboard. Okay, so I'm going to try to share my iPad with you, and we're going to get moving on this function review material. Okay, so if you haven't done so already, okay, if you have Canvas open in another tab from WebEx, okay, you might want to, take a look at this function review notes, or you can actually, up here, function notes, okay? You can actually print them off if you want, or you can look at them online. But this is what I'm going to be using to actually walk through the material. Okay, so first I have to share, and then I have to share my screen. So it takes a moment for the tablet to connect. Okay, so let me share content now. Okay, now everybody should be able to see section 1.1. Oops, wrong thing, my bad. Hold on. Functions notes. Okay, so everybody's seeing function notes? Okay, if you could just give me a shout out or in the chat. Can everybody see it? Okay, we want to make sure the technology's working.
Yeah, we can.
Good. Awesome. Okay, so I'm not going to read all this to you, okay, but I can kind of summarize it. Okay, so what's a function? It's a relationship between two quantities. One is called the input or the independent variable. Okay, in most of your experience, this is typically called X, but it doesn't have to be. Okay, and then the output variable is connected to it in a particular way, usually according to some sort of a function rule, right? Like take the input and square it to get the output. Okay, the output is the dependent quantity, which is either called f of x, right? Or it's called y, or it's called something else. Okay. So again, I like the terminology input and output. Okay. I find it's really, really helpful for students to kind of focus on those ideas. Okay? That one is the thing that goes in and the other is the thing that comes out. Now, any relationship can have an input and an output, but what makes a function particularly useful for modeling business situations is this word uniquely, okay? Each input value uniquely determines one output. In other words, if I put a certain number into something that's a function, I can predict what's going to come out of it. I never have a situation where I'll put a number into a function and then I have to guess which one of 2 or 3 or 4 outputs will come out. You can see that that would make it pretty useless as a modeling tool, right? If you couldn't predict the output. Okay, so essentially, again, I know I'm reviewing introductory algebra, but that's fine. Okay, it's worth a review. Okay. So basically, you put in a 2, you know you're going to get a 4. Okay, you put in a -2, you know you're going to get a 4. That's okay. as long as we're for sure we know what output will come. It's not okay to put in a 2 and decide, well, am I getting a 4 or am I getting a 5? Okay, that would be pretty useless. Okay? Okay. So let's talk about things graphically. Okay, your independent variable is typically on the horizontal axis in a Cartesian graph, right? A Cartesian plane. Okay, and the dependent variable, the output, is typically your vertical axis. Okay, I'm saying that because they won't always be f of x and x. Sometimes there'll be t and v of t. Okay, or there'll be n and s of n. Okay, so please don't be wedded to the names x and y. Okay, think independent or input variable like x, and dependent or output variable like y or f of x. Okay. And one thing that we're going to have to really focus on when we're doing applied problems is what are the units that those variables are measured in? Okay, particularly since most of the time we're going to be talking about how quickly things are changing. Okay, most of our units will probably be rate units. That means they'll have a numerator and a denominator, like miles per hour or cents per ounce. Okay, so basically take note of what your units are. I know a lot of students, in their haste to get an answer, a numerical answer, they don't pay attention to that. But the units can really help you solve a problem. Okay, and in a business context, they're important. Again, I'm sure you remember these words from introductory algebra, domain and range. So your domain is all of your allowed input values. What do I mean by allowed? Well, they're the values that if you plug them into your function, you get a defined output. Okay, if you wind up with undefined outputs in your function, then you have to exclude the input values that made those happen. Okay, so you might remember from college algebra that there were certain functions where you had to exclude things from the domain. So now I'm throwing a question out to you. Okay, what types of functions have values excluded from their domain? Okay, and again, feel free to either unmute yourself, type in the chat box. What kinds of functions? Anybody remember kinds of functions? I guess I'm just trying to see if anybody remembers any of this stuff. Okay, I'll put some function family names up here in the chat. Okay, so here are a bunch of different family names. Oh, and that first one is polynomial. Okay, polynomial, radical, rational, exponential, logarithmic. Maybe I should way. Okay, which of these functions, these types of functions, don't have values excluded from their domain? Okay. Anybody remember the well-behaved functions, the ones that aren't problematic? Anybody remember those from college algebra? And don't worry if you don't remember, it's okay. We're going to review it. Okay, I'm just trying to see how comfortable. Okay, that's perfectly all right to not remember. Okay, but let me ask you this. You do remember that there was some sort of nonsense going on where there were values of X you put in and bad things happened, right? You didn't get a defined output. And your instructor probably told you, you got to watch out for this. Okay, not to worry. Okay, So again, just remember what domain means. Domain means it's all of the inputs that give you a defined output, okay? And I'll show you examples of where that doesn't work, okay? Likewise, range of a function is what you get when you plug in the domain, okay? It's what comes out of the function once you plug in all the allowed inputs, the things that give you defined outputs, okay? So domain and range are typically used, indicated with interval notation. Okay, like for example, okay, now hopefully everybody can see me writing here. Here's a domain. Okay, this is interval notation. Okay, and it says that the domain is all real numbers. How do I know that? Well, the left end of the domain interval is negative infinity, which isn't a number, it's a concept, right? It means there is no negative limit on that side. You can go as low as you want. The right side of the interval is positive infinity, which again isn't a number, but a concept, meaning there is no largest number. You can get as big as you want. And again, the curved parentheses mean you can't actually touch those endpoints. Again, if infinity isn't a number, you can't ever get there. Okay. Here's another example of a domain. Okay, and I'll use some of these notations in a minute. Okay. This is a domain statement that says the allowed values are all real numbers between -2, including it, that's what the square braces mean, up to +4, including it. Okay, so this might look something like this if I were to graph it. Okay, so let's say we had -2 over here and 4 over here. And let's say I had just a linear function that was only defined between these two values. Okay. All right, so here you can see on the x-axis, okay, my function goes from -2 on the left, including it because it has a solid dot, and it goes all the way over to +4 on the right. A good way to visualize domain and range with a graph is to imagine you're riding along the function, okay, and you're looking back at the x-axis, okay, and you're looking at all the values you can see from your window on the function, okay? And you can tell I can see everything from -2, including it, all the way to 4, including it. So that's how I would describe domain, okay? If I were to look at range, okay, I would just simply look at the vertical axis, the output axis, okay? And I could see if I were writing on this function, I could see everything from -3 all the way up to +3, okay? So this function has a domain of -2, 4, and a range -3. Okay, is that helpful? Is that helpful as a review? Okay, anybody have questions about anything I've said? Okay. There are other ways that you can express functions, though, besides a function graph. Okay, lots of times they'll show you what's called a mapping diagram, which is this thing here. And then they want you to take this, okay, and create a scatter plot. Now, what's important to realize here is you have x and f of x or y, okay, in the scatter plot has x and f of x as well. Okay, so if you're trying to plot your mapping diagram, it would say -1 on x maps to -2 on y. Okay, so basically, if you wanted to draw that, you'd have to go to -1 on x and map it to -2 on y. So there's that first dot in the scatter plot. Okay, here you've got a 1 and it's mapping to -1. So you go to 1 on x and map it to -1. Okay, 1 is also mapping to 0. Okay, so if you take a look at that, you go to 1 on x and map it to 0 on f of x. Okay, then I've got a +2 mapping to a +2. So you go to +2 on x, +2 on y. Okay, so this is the ordered pair 2, 2. Okay, this is the ordered pair 1, 0, 1, -1. You get the general idea. Okay, so you're using the mapping diagram to make ordered pairs. And the last one is 3, 2. Okay, so that's kind of how you translate it. Okay. Now the question I would ask you, I'm asking you right now, is this a function? What do you think? You can either unmute and answer or type in the chat. What do you think? Okay, I'm getting some no's and some yeses. Okay. For those of you who said no, why not? Why not? What makes it not a function? Okay, and again, feel free to unmute and answer if it's too tedious to type. Okay. All right, I'm getting one statement saying there should be a unique output for each input. Which is the problem? Okay, which input has not got a unique output? Which one? Which input value, which x value is the problem? Okay, yeah, 1. See this guy right here? Remember we said if you're going to use this to predict anything, you've got to be able to know what the output is. So how do you decide? If I put in a 1 to this function, am I going to get -1 or am I going to get 0? That's a problem. Okay, this isn't a problem, the 2 and the 3 both mapping to 2. If I put in 2, I get out 2. No choice. If I put in 3, I get out 2. No choice. Okay, so you can see that's not a problem. Okay, so this is not a function. Okay, and the problem is 1 has 2 outputs, -1 and 0. Okay, and that's a problem. Unique means only 1. Okay, so because that 1 has 2 separate outputs, that's what makes it not a function. Although it's now a relation, it's not a function. Okay, so I'm going to change this from f of x, change it to y, right? Because it's not a function. I'm not using function notation. Okay, I'm just relating two variables, x and y. The domain is all the x values. So I'm just copying the things in the first part of the mapping diagram. The range are all the output values. Oops, curly braces. Okay, so domain and range are just the inputs and the outputs. Okay. Right here, we're going to do it the other way around. We're going to start with a list of ordered pairs. Okay, and we're going to draw a mapping diagram. Okay, so here I have a 1, and it maps to a -2. I have a -3 that maps to a -1. And here's 1 again. Everybody see this? One is showing up a second time, only this time it's mapping to a different output value. 0. Then I have 2 mapping to 2 and 0 mapping to 3. Okay, so what do you think? Is this one a function? What do you think? Is this one a function? No. Anybody else? Okay, no, it's not. Okay, so no. And it's for the same reason as the last one. One has 2 outputs. Okay, -2 and 0. So you can't tell which one you should pick. Okay, that's what makes it not a function. Okay, you might remember graphically, and you could see it here in this picture as well. Whenever you have 2 points that line up vertically like this, you've got a problem in function land. Okay, and again here, they kind of go over what you might remember as the vertical line test for the graph of a function. In other words, if you can draw vertical lines everywhere on the graph of a function and not hit it more than once, then it's a function. How do you know that? Well, that's telling you there aren't 2 output values for the same input. Remember, output values are going to line up vertically if they're the same. Okay? So what I have here in the first example is a function, yes, because it passes the vertical line test. Okay. Also, if I want to figure out its domain, what should I put in for the domain here? Okay, you can say it in words. You can write it as an inequality. You can write it as an interval. You have all of those available on your keyboard. What's the domain? What are the allowed x values?
-2 and 2.
Okay. -2. Am I including the -2? What do you think?
No.
No. Okay. So because I'm not including the -2, I have to use a curved bracket there. How about +2? We said between 2 and -2 and 2. Should I include +2? Yeah.
Yeah.
Okay. So it looks like this, which is a little weird looking, but that's what it is. Okay. So thank you, those of you who put something in the chat, but take a look at the lopsided parentheses and brackets. Okay. Hollow circle, curved bracket, solid circle, square bracket. Okay. Now, how about range? Remember, with range, you're going to be looking at the vertical values. What do you think? What's the range of this function?
-2 and 1.
Okay. Again, -2. Am I including it?
No.
No. Okay. All right. And then if you go up here, you can see this solid dot is opposite the 1 on the y-axis. So that one gets included. Okay, everybody all right with that one? Okay, so let me ask you questions. All right. You can ask questions about the idea of domain and range, or you can ask questions about interval notation. Any of this not making sense? Okay. Okay, let's take a look at, why did I say it was 1? Okay, it ends with 1 because remember, now when you're looking at range, you're looking at the vertical axis. Okay, ride along on the function and look back at the vertical axis. What numbers can you see? Okay, I can get almost down to -2, but there's an empty circle here. So I'm not going to include -2. But then as I move along the graph, I can see all of these numbers. all the way up to what? What's the highest number on the y-axis I can see? The positive 1. Okay? Does that make sense? Okay, good. All right. Well, let's take a look at this example. Okay, I think everybody would agree if I draw vertical lines, I'm failing the vertical line test in spades. As a matter of fact, there's only 2 places where I pass it, right here and right here. Okay, so this fails the vertical line test. Okay, so I know right away it's not a function. Okay, because again, you can see this y value and this y value both come from an input of -2. Okay, let me get my lines off of here so you can see it again. Okay, so this y value down here and this y value up here both have an input of -2. Okay, so again, not a function. Now suppose you're interested in the domain of this function. What is the lowest x value you can see here on the graph? Again, make believe you're riding around in a circle, right? Here is the point where you are the furthest left, then you start coming back to the right again. Here's the point where you're the furthest right, then you start coming back to the left again. So what's the furthest left value you can see?
-3.
-3, and you're actually touching -3 right here. Okay, this line, the circle graph actually touches this point right here, -3 and +1. So I'm going to use a square bracket. And again, coming around to this side, here's the furthest right I am. What's the high end of my domain? What do you think? Right over here. +1. And again, the circle is touching the point 1, 1. So I'm going to put a square bracket on that domain. Okay, let's see if you can do range by yourself. What is, again, right around on the circle, but this time instead of looking at the horizontal axis, look at the vertical axis and look for the lowest value you can see and the highest value you can see. Okay, so I'm asking you, what's the range of this relation? All of these boxes are 1 apart. I realize they drew on top of this one. Right, okay, the lowest one is -1, and the circle actually touches the point -1, -1, right here. And if I come up here, the highest value is +3, okay, and the circle actually touches the point -1, +3. Okay, everybody okay with that one?
I have a question.
Sure.
How do you know if it's included in this circle because you don't see any dots on it?
Okay, when you see a solid graph like this, okay, you're assuming that this is touching this right here and here and here. Because again, the line is going through this crosshair point. Okay, so normally you won't see big dots like this unless you've got a domain that's restricted like this one is. Normally this line would go on forever, right? But they're just showing you a piece of it. Here, if you're looking at a smooth graph, if it looks like it goes through a cross piece like this on the coordinate plane, you're assuming that that point is included in the graph. Okay, so it's pretty much like, does the graph go through that point? Is that kind of answering your question?
Yes,
And
thank you.
And again, if it's not clear in a particular instance, feel free to ask. Okay, if it's like, I can't tell in this graph whether I'm supposed to include it or not, ask. Okay. All righty, let's take a look at some of these. All right. This is an interesting squiggle of a graph. Okay, and again, it's kind of difficult when you're looking at something like this. It almost looks like this is going vertically, but it's not. If we were able to blow it up, you'd see it's coming ever so slightly to the right. Okay, same thing here. These are not lined up vertically. Okay, so I'll tell you right off the bat, yes, this is a function. Okay, it does not fail the vertical line test, even though it might look like it does. Part of the problem with drawings is the line here, the red line, has a certain thickness to it. So it might look like points are lined up horizontally, vertically here, but they're not. Okay, and again, like I said, if you're ever unclear about it, ask. What do you think the domain is here? Let's ride the squiggle, okay? I can see almost to -2, but you can tell there's an empty circle there, so I can't actually see -2. And then I'm going to the right, okay? Here I'm looking at 0 on the x-axis. Here I'm looking at 1. Here I'm looking at almost to 2. So what do you think the domain is here? Okay, and tell me what kind of brackets to use too. What do you think the domain is? Okay, can everybody see what Fabian typed in? What do you think? Anybody have any other ideas?
Since for the domain, hold on.
Yeah. Okay, so the idea, Jacob, is look back at the x-axis, right along the curve.
Yeah, so we would put a 0 in there.
A 0. You mean a 0, or do you mean, where do you want to
Since
put?
will it go through for the x-axis? It goes through the y-intercept, right? The y.
Right. All you're doing here, I understand what your confusion is. Okay, and you're getting the notation confused with an ordered pair. You're absolutely right. Y-intercept here is 0, -2 in parentheses, but that's the y-intercept. What we're
Yeah.
asking you here is, what are all of the allowed x values? So Jacob brings up a good point. Okay, here is the y-intercept, or the vertical intercept. Okay, I'm writing it on here. And that's 0, -2. Ordered pair. Looks like an interval. Isn't that confusing? I totally agree. Okay? But in this example, here's x, here's y. Because a y-intercept is an ordered pair.
Oh yeah. What I was meaning is we
Right. About a domain, though, everything's an x value. There's no
if
xy.
we add
Okay?
the 0 to
You
that.
don't have to. You can just include it. Here's the idea behind a domain interval. Let's say it's -2, +2. You're including all the real numbers in between,
Oh, okay.
okay, including the 0. Okay, so you don't have to put it in special. These are great questions. Okay, so please keep asking them. Okay, now is the time to make it click. Okay, so you can use it as a tool going forward. Okay, part of what you're trying to do is stock a tool bag with all the different types of tools you'll need to be able to function mathematically in your career. No, every tool needs to be a hammer. Sometimes you need a screwdriver or a wrench. Okay, so that's what you're trying to do here, is to build a toolbox. Okay, so please ask questions are great. Okay, so the trick here, this is an x value and that's an x value. Do you see the difference? Even though these two things look almost identical. Okay, how do we know? Oh, I love it. How do you know when to use parentheses or a bracket? If you're including the number in the endpoint, right? Like here, if this were a solid circle, this would be a square bracket. Because this is an open circle, we're not including -2. We can get as close as you want to it, but we can't include it. So that's why we use parentheses. Okay, so solid circle, where the graph goes through that point, that x value, then you use a square bracket. Otherwise, if it's a solid, an empty circle, or it's infinity, you're going to use a curved bracket. Okay, think of it like this. Square brackets you can grab hold of. Okay, it means you can grab a hold of that number. Okay, a smooth bracket, like a parentheses, imagine sliding off. You can't grab a hold of it. Okay, so that's kind of a memory thing that can help you remember when to use square and when to use parentheses. Does that help? Okay, let's take a look then at the range in this function. Okay, so we're going to look at the y values. Okay, so again, if we ride along the curve and we look back at the y-axis, what can we see? I'm going all the way down here, and then I'm coming back up again, and then I can see these, and then I can see them again. Okay, so again, I rode the curve, but I was looking back at the y-axis. What values do you think the range has? Okay, and again, I'll try to erase some of this so you can see the values. Okay, what do you think is the range? Okay, I'm getting some suggestions. Okay, so again, this curve comes all the way down to -4 over here. Okay, this point right here, somewhere between -1 and -2 on x, but it's hitting -4 on y. Okay, so the low end is -4. And then you can see as I travel up the curve, the highest value I hit right here is y equals 0. And then I start coming back down again. Okay, does that make sense? Okay, it's really difficult. I can see from some of your answers in the chat, some of you are having trouble defocusing from X and focusing on Y. Notice the lines I drew are now pointing at the Y axis, not the X axis. Okay, so yes, the domain goes from almost -2 to almost +2, but the range goes from absolutely -4 all the way up to 0, including it. Okay, if I'm looking at the vertical values. Okay, another way to imagine it is imagine you had a table of points for this graph. Okay, it would be an infinite number of points, but let's say you had part of it. You would be able to see y values that got as low as -4 but no lower, and y values that got as high as 0 but no higher. Okay, does that make sense? I know this is a sticky concept. I really do. Okay, no matter how many times we go over this, I know it's sticky. Okay. All righty. Let me get rid of the scribbles. Hopefully, if you drew your own pictures, you've got your scribbles. Okay, and that will help you understand how to do it. Here's a really interesting function. Well, it's not really interesting, but I put it in here because I want to make a point. Is this a function? Does it pass the vertical line test? Okay, so some of you are saying yes, yes, yes. Yes, it does. Okay, it's not a very interesting function. Okay, it's a constant function. Okay, what I've graphed here is the line y equals 2. Okay, it's a constant function. So no matter what input you put into it, and its domain, because of my arrowheads, goes from negative to positive infinity. See the arrowheads? Okay, so I can put in any real number as an x value, as an input value, and what comes out? Okay, it's really hard to draw this as an interval notation, so this is set notation. Okay, intervals usually have a high and a low value in them. the leftmost value is the lowest value, the rightmost value is the highest value. I've only got one value here. Okay, so I put it in a set. Okay, so this is kind of a one-note function. No matter what you throw at it, it says 2 back to you. Okay. All righty. So what can we do with these? Well, I'm sure you remember this. You can either evaluate them. Okay, in other words, tell me what the output is if I give you the input. Okay, where you basically use a calculator or some other tool to a function rule or a graph, and you can evaluate it. Or you can solve, which is the reverse. Okay, solving means I gave you the output and I want to know the input. Okay, so at this point, okay, let me ask a survey question. How many of you have a TI-84? So if you have a TI-84 with you now, okay, just type me or yes in the chat. Okay, me. Okay. Yes, yes. Okay. All righty. The reason I'm asking is I have no problem showing you how to do things on an online calculator or a TI emulator, which I also have. Okay, I need to know what you're comfortable with. A TI-84 is a Texas Instruments graphing calculator. Okay, so basically, if you have one, that's great. If you want one, you can use that technology request form I showed you in our Start Here module in Canvas to get one from the college. It doesn't have to be a TI-84, but again, I can only like show so many different things. Again, if you're comfortable with the calculator you have, by all means, use it. Okay? I don't want to break what's already working for you. But let me just show you. I want to go back and let's see, how can I do this? I want to go back and share. I think I already shared my browser, so I don't want to stop sharing it. Get back to it. So. Okay, never mind. I wanted to show you the TI of the Desmos. Okay, I have not only, hold on. Here's what I can do if you want to see the TI-84, is I can show you that. Okay, again, I don't know if anybody can see that because again, I'm having a problem here. Okay. It's not letting me switch, which it normally does. Okay. So again, my bad. I apologize. Let me just stop sharing briefly. Okay, never mind. Okay, let's keep going here and I'll show you Desmos in a minute and then I'll figure out what's going wrong with WebEx. Okay, technical issues happen, not a problem. I'll try to keep you apprised of what I'm doing so you don't think you are lost. Okay, I just had a technical glitch there with WebEx. But again, I can show you how to do this on an online calculator called Desmos. I can show you on your TI-84, it doesn't matter. But let's take a look at evaluating a function. If you look at example 7 here, I'm asking you, what is the output? I'm saying, what is f of -3? What this means is, what's the output when the input is -3? Okay, so basically, you go along, very good. You go over here to -3 on your input variable line, right? Your horizontal axis. You go up here and you find the ordered pair here, -3, 1. Okay, so f of 3 is 1. This is called evaluating a function. Okay, and here's an example of solving. And again, you can do this algebraically as well. You can also do it from a table of values. I'm showing you how to do it graphically. Okay, it's important when you're doing math to be able to switch between all of these. Okay, here's where we're actually solving, and we're asking for what values of fx is f of x equals 0. So now I'm saying my f of x is my y value. Where is y 0? Well, y is 0 here, and here, and here, and here. Remember, the x-axis is the line y equals 0. So if you wanted to list these x values, that would be -2, 0, 4, and 5. Okay, so that's kind of the difference between evaluating and solving. And we're almost done, don't worry. Okay, here's examples of how to do it algebraically. Okay, if you wanted to evaluate f of -6, you would just say, type this in on your calculator. Remember to put negative numbers in parentheses, right? And you would type this in on a calculator. Okay, it's a good idea to have a scientific calculator. Okay, and again, if you don't have a TI, okay, I've put a link in that online tools section to a Web 2.0 calculator. Okay, you can also use Desmos, and you can actually click on the value, okay, that is showing for x equals -6. Again, I'm trying to get this to behave, and it won't. Okay. Okay. So again, we'll show you this in a minute as soon as I stop sharing. And over here, solve the equation when f of x is 0. So then you take the f of x side and you substitute the 0 for that side. Okay, it's important to pay attention to which side you're putting the number in. Okay, here it goes in for x, here it goes in for f of x. Okay, and then basically we try to factor the equation. Okay, if not, you can always use the quadratic formula. Okay, you use the zero product property that says if the product is 0, then one of these has to be 0. And then you just solve each of the linear equations. Okay, so there are two values here that give you a 0 because it's a quadratic. Okay, so there's a kind of an example of evaluate and solve. Desmos, the online calculator I have linked into the course, is really helpful for doing this. This is kind of clunky on a TI-84. You have to use the second calc menu. You use value for this. And over here, you pretty much have to put two things in your y equals. You have to put the right-hand side and the left-hand side, and then you have to figure out where they cross. I much prefer doing Desmos because I can just click on a graph. Okay, and I'll show you that in a moment. Okay, before we end, I just want to re-evaluate here the basic toolkit functions. Okay, You've got linear functions, okay? F of x equals x or y equals x. Okay, a constant function where this is a number. This is like our y equals 2 function. Absolute value functions, okay, these are the ones that graph kind of like this. Okay, quadratics, which graph as parabolas. Okay, cubics, you might remember they kind of graph more like this. Or the other way around. Okay, so basically you'll see graphs on the next page. This is your, it's called a reciprocal function here, but you can also call it a rational function. Okay, these are the ones that look like elbows. So you have one like this, one like this. These are the ones that have vertical asymptotes usually. And a reciprocal squared is another type of a radical function that looks like that. Okay, and again, we've got square roots, kind of looks like this. Cube root looks like a cubic on its side. Okay, and again, you can kind of see basic shapes. We can pick these up and move them around, but it'd be a good idea to be able to recognize basic shapes like this. Okay, I just want to take a minute and look at this brief application problem, and then we'll come back to the meeting and I'll show you Desmos. Okay, the amount of garbage a city produces with a population P is given by G equals F of P. G is measured in tons of tons per week, and P is measured in thousands of people. Okay, the town of Tola has a population of 40,000 and produces 13 tons of garbage a week. Express this in function notation. Okay, now they're telling you here is your input, okay, this is your P value. Okay, so it's 40,000, but population is measured in thousands. Okay, so this is a scaled number. Okay, so we would say P equals 40. Okay, because again, we're measuring in thousands. Okay, F of P, the amount of garbage, which is G, okay, G equals F of P, is 13 tons. Okay, because again, G is measured in tons per week. So if you wanted to write this as a function notation statement, you'd say F of 40 equals 13. Okay, this is critical to be able to understand from the words. Okay, the first thing I had to do was scale my input, and then I had to put it in the right place. Okay, 40 is a P value. Okay, and notice the 13 is on the opposite side of the equal sign from F of P. So that's a G value or an F of P value. Okay, let's see if you can do this last one. Okay, explain in words F of 5 equals 2. Okay, and I don't want to see P's or G's. Explain it in terms of garbage and people. What does that mean? Anybody have any ideas? You can start out this way. When the population of Tola is, start it out like that. When the population of Tola is what? Where's your population value? Okay, great. When the population is 5,000, the city produces 2 tons of garbage per week. Okay. This is critical to be able to do. Take your time and actually look at the units, figure out what's input and output and what they're measured in. Okay. This is going to be critical as far as being able to set up and solve applied problems. Okay. So I'm going to stop sharing. Okay. And come back to the meeting. Okay. Briefly going to go and show you Chrome again. And I want to bring up, oops, the Desmos graph. Hold on. Okay. This is desmos.com for those of you who may or may not be familiar with it. And I'm going to type in that function we had there a minute ago, which was y equals x squared minus 3x minus 40. Okay, and you can see I have a really big quadratic here. This is zoom in, zoom out. I'm going to zoom out a bit so you can see the whole quadratic. And remember, we wanted to know what was the value. Remember I said evaluate it when x was 6. Okay, so if you want to zoom in a bit to see where 6 is. Okay, here's 6. I'd have to go over here. I guess it was -6 I was looking at. Okay, so here's -6. And I can scroll all the way up to the function over here to see where it crosses -6. And you can see the value right there. Okay, I didn't have to do anything with my calculator. Okay, you can just click on points. It shows you x-intercepts. It also shows you maxima and minima. Okay, this may or may not be helpful if square roots are involved. Okay, but I strongly urge you, okay, get familiar with Desmos. Okay, get familiar with Desmos. It's super easy to use, and it covers a lot of the graphing functionality of a TI-84, except it's a lot easier to use. Here was the other web tool I wanted to show you. I wanted to show you the Web 2.0 calculator. If I can just get my WebEx stuff out of the way, but it's not cooperating. Anyway, the Web 2.0 calculator is a scientific calculator, and it will save. Unfortunately, it has lots of ads that pop up alongside. This is Web 2.0 Calc. You can use calculator notation to type things in. Okay, like this, but it will render it in actual mathematical notation up here. You hit enter to get a value, okay? And then it's in your history down here. So if you ever want to, like say, oh, I didn't mean to type a 4 as the exponent, I wanted a 5. Click on it, it's right back in there again. And now you can run it again. This is a really, really useful scientific calculator. Okay, so please try scientific at Web 2.0. Okay, so try it. So if you've got a TI and you want to learn how to use that better, feel free to hook up with me with a WebEx meeting. I can show you how to do that. Okay, so I'm going to come back to our meeting and ask, does anyone have any questions about anything? Anything we covered today, either about the course, about how it's set up, about any of the math we reviewed? Anybody have any questions about any of